This is Team Lannister Lions, and we have worked on a project for generative AI, large language models, fine tuned for legal practice platform. And our team has Nikhil, Vineet, that's myself, and Jaideep. So let's get into it. What we have created here is basically a legal platform that is a one stop solution for any kind of information that a legal professional might want. So, this information includes any of the cases that the lawyer has worked on or has been involved in, and all the legal, laws of this country, the legal documents that we have. So that includes the Indian Penal Code. So we have used all of this information and created large language models. We have fine tuned them, and we are doing further retrieval augmented generation as well on them. So let's look at some of the key features. So the architecture basically is uh, heavily based on one API AI toolkit. So we have the large language models that we have pulled from Hugging Face, that is Llama 2. So our whole basically pipeline is built upon Llama 2, and we are using Llama Index for the retrieval augmented generation. Uh, One API we have used for optimizing the transformers, which is the Llama 2 transformer, and that has helped us quite significantly in the CPU based server that we are using. The whole application, which includes the React UI that we have created and the Python backend, which has the whole pipeline for the large language model, the whole thing is deployed on Intel Cloud. So let's look at the architectural diagram here. So as I said, the platform deals with all kinds of legal information, which is the lawyer's cases plus the Indian Penal Code. So that raw PDF we have put it through the Llama 2 model for generating a question and answer dataset. This prompts dataset is used for fine tuning the Llama 2 model itself, which we have done with the help of PEFT and QLoRa methods, along with the SFT trainer that Hugging Face has. So here we have used again one API for optimizing the transformer model uh, before fine tuning it, so that the fine tuning process is smooth and easy. Coming to the next steps, which is putting the fine-tuned model on Hugging Face and then pulling it into the deployment. The deployment has the inferencing code that we have. It is a CPU compute, and it has the Python optimization from Intel. So PyTorch basically is used here, and Intel's extension for PyTorch, which is IPEX, for optimizing the model. And we have the vector database store for keeping the PDF documents, which will be used for the retrieval augmented generation process. So the key thing to note here is that we have first fine-tuned the model, which makes it a subject matter expert on everything that is legal. And then we have provided retrieval augmented generation to get fine-tuned, precise information from the context of the question that the user asks. So these both of these techniques combined give a very precise and very comprehensive answer. So we have exposed this through an endpoint for the user interface to use, and the user interface is again deployed on the cloud, the Intel cloud, and we have also streamed the requests and response that the large language model provides to the user, that can be shown on the UI. Now coming to the AI analytics toolkit that we have used. So as I said, Intel extension for PyTorch. We have also used Modern for dealing with the large uh, text data that we had, and then Intel's distribution of Python. The whole thing is running on Intel's Python. So, and as I said, the whole thing is on cloud, Intel Developer Cloud. So we are using a CPU instance for that, and the one API toolkit has really helped there, as we'll see in the next slide. So we have some benchmarks here with and without the Intel optimization. As you can see, inference times have reduced quite a bit with Intel's optimization. We have basically used IPEX to optimize the transformer model, and memory usage as well as has drastically reduced. We have 17 gigabytes when we are using Intel's optimization as opposed to 32 gigabytes. So this is the whole overview of the project. Now coming to a UI demo. So I'll hand it over to Jaydeep. Before that, let's see. Let's basically make the backend connect to the backend to the Intel cloud, and uh, basically create the connection. So the Intel Developer Cloud. So we are logged into the Intel Developer Cloud. We'll go to our project, and then we'll basically we have created a environment, Conda environment with the XPU and related libraries. So we'll activate that, and then we'll basically start the instance. So we have this script here which basically starts a Flask environment, Flask API, and that has exposed the model basically for us. So okay, I think there's some issue with the activation of the environment. Let me just check that. Okay. All right, so we have activated the environment, and we are starting up the system. So this script includes in the inferencing code, which is running the large language model along with intense optimization. So as you can see here, we are getting the model. It's basically in the cache. The cached model will be then optimized using Intel's IPEX optimization, and then uh, that is what is happening right now, the optimization process. And then we will be creating document stores for all the various PDFs. So as you will see in the UI, you can do question answering on a global level, so which will include all the information that we have, the Indian Penal Code as well as all the PDFs. Along with we also have specific contexts, so which will be specific cases for the lawyer, as well as some specific uh, rules or laws of this country that they want to do question answering on. So let's get into the UI. I think the backend is almost up and running. I'll hand it over to Jaideep to take over the next part.
Yeah, okay. So thank you, Vinit. So yeah, now I will walk you through the UI. So this is the UI. So first let me log in. Uh, Let me log in with my email address and password. Similarly, if you don't have any account, you can create an account. So yeah, now I am logged in. So you can see the dashboard. So here all the profile details of this user is mentioned. The user can update the profile also, simultaneously the number of case won and the lost. Moreover, also you can ask any question related to Indian Penal Code, and you can also ask any question, any generalized question related to law or any PDF or any cases or any documents. So let me walk you through one of the scenario where you can ask any question related to Indian Penal Code. So let me ask, what does Article 1 state right in one sentence? So yeah, so let me see what response does it gives. Yeah, so here all the UI and the UI is made in React, and the Python backend, everything is deployed on IDC on a single CPU instance. And here, since we are using the CPU instead of GPU, so the token generation time is comparatively less. So that's why you can see a little delay in the response. So that's not the issue, that's not the major issue, since if we use GPUs, the response will be quite fast enough. So yeah, you can see the response is coming, and we have also done streaming. So that's why you can see the streaming response instead of the entire response at a time. So yeah, you can see the response now coming on the screen. Mm. So yeah, you can see the entire response is over. Yeah, the entire response came. Similarly, you can ask other question also. So now if I go to any of the case, these are the cases that the lawyer has shown. See, you can also filter the according to the parameters. Suppose if I go to any of the case, and you can also ask any case specific question. Suppose let me ask who is the lawyer for this case, or since it is case specific, I can also ask like who is the lawyer. So it will take the instance of this case and will find out who is the lawyer of this case. So yeah, the response is coming, and you can see the typing, the case whisper is typing. The case whisper is actually the name of our platform that we have given. So yeah, and on the left side you can also see the summary of the case, this case, the summary. And the yeah, you can see the lawyer name is Vinish, and the lawyer name is Vinish Jain. And let me also ask any another question, like where did this happen, like where did the case happen or something like that. uh, so let me ask. Similarly, you can also ask any related question related to this case, and it will in turn help the lawyer or help any legal professional to find the specific information in the document very much accurately in a short time, without going through the entire documents or without reading through the entire PDF. So you can see the response is coming. So yeah, this is all about our UI, and now I will hand over to Vinith to demonstrate the use case of Intel One API in our code. Over to you, Vinith.
Thank you. So let's look at the fine tuning process first. So this is the script that we have used for fine tuning, and we have done quite a bit of changes for CPU optimization. Uh, Again, as you can see on top, we are using PyTorch along with IPEX, and as I mentioned before, PEFT with the LoRa configuration, and the SFT trainer from Hugging Face. So here are some parameters. Uh, we are using some LoRa parameters here, and then bits and bytes, and we are using the BF16, which is the floating point precision of 16, and then coming down to the optimizer, which is Adam optimizer here. And now we come to the fine tuning process. So before fine tuning, we are determining the device to be used. So if XPUs are available, XPUs will be used, otherwise it will be a CPU fine tuning CPU device that we will fine tune on. So here's the bits and bytes configuration. We are using 4 bits for optimization on CPUs. Coming down to the model, which is the Hugging Face model, the transformer. We have put the selected device, and then we are having the IPEX optimization. So we have applied that IPEX optimization, which helps the model quite a bit, reduces memory and time taken for the total fine tuning. Then coming to the training arguments, so these were defined above. We have used them here. The SFT trainer we have prepared, and then we start the training process here. So this is pretty standard process of fine tuning. Once the fine tuned model is saved, we save it and push it to the Hugging Face, uh, our repository on Hugging Face. Now, coming to the next part, which is the inferencing. So, uh, before inferencing, we have this script as well for creating the fine data set for fine tuning. So this is also pretty standard. We have used llama index and llama 2 for creating the data set. So here what we are doing is we are asking llama to go page by page. So we are feeding llama 2 all the PDFs page by page, and we are asking llama 2 to create some questions and their answers for that particular page. So this way we get a good amount of prompts for each from each you know uh, PDF and each page of the PDF that we use for again fine tuning after this. So this is the basically some scripts that we have written to retrieve the questions from the generated questions that llama 2 gives. So we pass that whole response and get the questions and then get their answers, store that in a CSV file. Again, we have used the modern uh, you know uh, framework that Intel provides for pandas. Then coming next to the inferencing part. So this is the script that we were running on Intel Developer Cloud, and this script basically again has IPEX, pandas along with PyTorch, and uh, it has pretty much the same kind of optimization that we have seen on fine tuning. So we select the device and then the model, we get it from Hugging Face, and then we apply the optimization right here. So again, IPEX optimization on the transformer. Then we create a Hugging Face LLM model. So this is all based on the llama index framework, and then we get the embeddings model, create a service context, and then uh, we create all the vector stores. So we are beforehand creating all the vector stores from all the PDFs that we currently have, and then storing them in memory. So once that is done, we have the Flask API right here. So we have the one Flask API, which also streams the responses, takes the question in, it does both. So as you can see here, once a question comes up, we create a separate thread which runs and generates the response on the side in a separate thread. And if the API is called again to retrieve the answer, we give the answer which has been generated by that separate thread, right? So that's how we stream the answer basically. And that is about the inferencing part. And then we have performance comparison script, which basically we have used to generate those graphs and look at the memory usage as well. So as you can see here, we have run this model with both Intel optimization and without Intel optimization. The times are quite different here. We have 21 seconds and 41 seconds with and without. And this is the performance comparison chart for that. So this is our project, and it has been quite fun developing it on Intel on the cloud platform, especially because the cloud platform is quite free to use. It is a bare metal server which has given us sudo privileges as well, so it's quite convenient to use it. And Intel optimizations definitely help here in speeding up the process.